This is the beginning of the Unit 3 4A retest review. We're going to start off with vocabulary. Just rather than go over this with you, just want to give you a heads up. Review this before the test. Make sure you understand the different definitions and especially the different forms of quadratics and how to identify those. You can see here over on this side of the page you've got intercept form, standard form, and vertex form. Common mistake on the last test was not knowing what the zeros or solutions were. That's another name for x-intercepts. They all mean the same thing. And let me see, was another common mistake? Oh, on domain and range. Domain is possible x values. Range is possible y values, and to keep those straight, one of the things you can do is you can just think to yourself, okay, domain starts with a D and range starts with an R, and if you think alphabetically D comes before R, then the x values come before the y values. X comes before y, so domain is the x values and range is a name for the y values when you're graphing. Okay, let's take a look at question number 1. By the way, this review sheet is set up so that there are multiple practices of the same skill. So I would advise you to try to do the problem before you look at the answers. And if you don't have the answer correct, then listen to the video and see if you can figure out what you are doing wrong and then try to correct it in the next question. So please don't just copy the answers. If you did that the first time around, that's probably what caused you to not get a very good grade. So this time around, make good use of the review sheet and do the problems first, then check your answers, and if you got wrong answers, then go ahead and listen to the video. Don't just copy the answers, listen so you understand how to solve them. So here we go. I'm going to go through these fairly quickly. What are the x-intercepts of this equation? Class, we learned that for the x-intercepts are always where y equals 0. So that means if x plus 14 equals 0, the whole right side changes to 0, and that means it equals 0 for the y value. If x minus 2 equals 0, then the whole thing changes to 0. So the way you set this up is you just break up your two binomials. What makes this equation true? What value of x makes that equation true? What value of x makes that equation true? Well, this one is negative 14. And this one is positive 2. So we've got a negative 14, 0 and 2, 0. Let's take a look at the next one. Number 2, what are the x-intercepts of this equation? Well, same thing applies. X-intercepts are where y equals 0. And if y equals 0, then either one of these binomials could be 0 and the whole right side changes to 0. So all you got to do is figure out what value of x changes this binomial to 0 and what value of x changes this binomial to 0. Well, this is 11 because 11 minus 11 equals 0, and this is negative 5. Negative 5 plus 5 equals 0. So our x-intercepts are negative 5, 0 and 11, 0. Okay, the next one. What are the x-intercepts of this equation? Again, notice the first two class, they are intercept form. That's why it's easy for us to find the x-intercepts. This next one is also an intercept form. A little bit more complicated though, but not too bad. Again, our x-intercepts are where y equals 0. So that means either we have to find the x value that changes this binomial to 0, or the x value that changes this binomial to 0. If either one of these binomials is 0, 3 times anything times 0 is going to give us 0, which means our y is 0, which means it must be an x-intercept. So this one's easy. 2 minus 2 is equal to 0. This one we got to do a little math. Let's go ahead and add 5 to both sides. And we'll see that we have 2x is equal to positive 5. Then we've got to get rid of the 2. This is multiplication. Multiplication is undone by division, which is the opposite operator for multiplication. 2 over 2 changes to 1, and we end up with x equals 5 over 2. So our two solutions here are 2, 0 and 5/2, 0. If you put that in your calculator, you will get 2.5. That is also an acceptable answer here. Okay, number 4 is very similar to number 3. What are the solutions of this equation? Again, we want to figure out, it's intercept form, we want to figure out what will change this binomial to 0 and what x value will change this binomial to 0. Well, this one is just positive 2. So in this case, it's asking us for solutions, not x-intercepts. Well, they're the same thing. The only difference, class, is for x-intercepts, you're going to write it in coordinate notation. For solutions, you're just going to give me the x values that change the whole equation to 0, which means it must be an x-intercept. So our first number here is 2. I'm going to wait to solve the next one first. This one we have to do a little bit of math. We're going to subtract 4 from both sides. And we end up with 2x equals -4. To get rid of the 2, you can't subtract because 2 is multiplied times x. The opposite operator for multiplication is division. That will undo the multiplication. The 2's cancel. And we have x is equal to -4/2. And that one, class, I can actually simplify. Actually, let's not circle it, because I can simplify that. -4/2, both of these are divisible by 2, and I end up with -2/1, which I can simplify to -2. So our answers here are -2 and 2. Number 5, what are the solutions of the equation? Again, solutions are just x values. You don't have to write them in coordinate notation. Let's split up our two binomials. So I've got the binomial x minus 3. What's going to make that equal to 0? Or my other x value that is a solution is what is going to make this binomial equal to 0. This one's easy. 3 minus 3 equals 0. This one we got to do a little math. Let's add 2 to both sides to move the constant to the other side. We've got 3x equals +2. Undo the 3 by dividing by 3. The 3 cancels the 3, and we end up with x equals 2/3, and that one we can't simplify. So our answers here are 2/3 and 3. Now 2/3 is a repeating decimal. I'd rather have you leave it in fraction form, but if you actually wrote 0.67 or just repeating 6 here, then that would be totally fine as well. So 0.67 or repeating 6 would be fine, but I would rather see it in fraction form. Alright, we'll end this video getting through question 5. We'll start question 6 on the next video.